Thank you everyone for joining. For those who missed the first intro, I'm Georgina Smit. I'm hosting the talk today. I have the pleasure of introducing Georgina Smit from the Green Buildings Council, South Africa. She heads up the technical department in charge of building certification and research around built environment and green credentials and all that in South Africa. We go way back to days at Arab together, and Georgina was part of the team that put the first Green Star rating system for residential, I think it was, in way back in the 2000s from it. So today Georgina is going to be talking to us about part we can play as structural engineers in reducing our carbon footprint. She's going to unpack the net zero carbon landscape for us and how it applies to the built environment. And she's going to focus specifically on our role as structural engineers and what part we can play. Just a bit of admin. If you've got any questions, please type them in the chat box on the side and we'll get to them towards the end. And please keep yourselves on mute and cameras off. Hand over to Georgina now. Thank you very much.
Thank you, Chris. Hi, everyone. Thank you also for the invite. It's great to be here today. It's a really exciting topic. You know, engineers have such a vital role to play in transforming our built environment, and the GBCSA is obviously very passionate about that. So I'm delighted to be speaking to you today. Okay, great. Can you all see my screen?
Yes, we can.
Okay, perfect. Okay, so in the next hour, we're just going to go over three main topics. A brief intro to the GBCSA. I think most of you know who we are and what it is that we do, so I won't be spending too much time on that. And then I'm going to chat to you about the net zero landscape in South Africa, and you know that would speak both to operational carbon but also to embodied carbon, and then focus a bit more on what I think, you know, based on our perspective and experience with projects to date in the green building environment, where structural engineers can leverage either changes or improvements to try and drive a decarbonization of the built environment. So please, yeah, I would love any questions. This is an exciting topic. I'm not a structural engineer, so this is not going to be about, you know, timber versus steel. I'm not going to get into those kind of details. It's more around understanding strategically what the opportunities and what the challenges are. Okay, so for those of you who don't know, the GBCSA is a not-for-profit, and we are really there to advocate for a green and sustainable built environment. We have over 400 members. We also support African GBCs, which I think is really important, and we collaborate with them and support the growing green building movements within the African continent, and we believe very strongly in supporting that movement. Many of you might be familiar with the GBCSA through our role as a certifying body. So we are the verifiers or the auditors of projects that claim to be green. Many of you might be familiar with the Green Star rating. You potentially have worked on projects where you had to have an input with the concrete and the steel credits, always the go-to for the structural engineer. And then obviously we offer a lot of training. If there's anybody who would like to know more about the GBCSA, because I'm not going to spend a lot of time on this, please drop me a mail and I can go into more detail. So the World Green Building Council did a mapping exercise where they mapped the Sustainable Development Goals, which are our key development agendas, to green buildings, to demonstrate how green buildings promote these SDGs, their agendas and their targets. And as you can see, there's a range of issues that green buildings speak to that are very important for us to move forward as a society and as communities. So the race to zero, net zero carbon, net zero water. I'm sure you guys have, as structural engineers and within the built environment, you're familiar with these terms and you've been exposed to them, in many different formats. I think maybe just to iterate that, this process started quite a few years ago where there was an acknowledgement around, the fact that we've got green buildings and they're great, but we actually need to do things far more radically. We need to accelerate change at a faster rate. And instead of doing a little bit less bad, we actually have to make sure that we either neutralize or redress our impact. And this is where the concept of net zero carbon, or any form of net zero, came out. So it was around regenerative design principles that emerged. So the GBCSA is part of a world Green Building Council network, and it's like part of our bigger family. And we participate in the Advancing Net Zero program. And the goal here really is to make sure that net zero carbon buildings and their uptake is accelerated, to raise awareness around this target, but to make sure that all buildings are net zero carbon by 2050. And this is obviously aligned with a lot of research that looked at the trajectories that we need to be on in order to reach the Paris Agreement, to make sure that global warming, doesn't exceed 1.5 degrees. And so the GBCSA is a part of this program. And interestingly, just, as an anecdote, we were very instrumental. I wasn't with the GBCSA at the time. Some of you might have engaged with Manfred Braun and Tyrell a few years ago. We're very involved in this program, and the South African GBC, the GBCSA, participated heavily in researching and contributing towards a lot of the definitions for net zero carbon. So I think fundamentally the most important element, or one of the most successful elements of this program, is that it has communicated and consolidated a very clear target. Whether the target is achievable or whether it is appropriate, those are both separate technical and detailed debates, but it put a clear line in the sand of saying that by 2030, all buildings need to be designed to be net zero carbon, and that's not very far away. And that secondly, by 2050, all new buildings as well as existing, so looking at the existing building stock, needs to either be retrofitted or obviously refurbished to achieve net zero carbon emissions. So these are bold goals, but I think it provides a very clear North Star for which to aim. So I think my question to all of you is, A, do you know about these targets? And more importantly, how are they being implemented on the projects that you are working on today, and how are they being raised? I think maybe just to note that when this target came out, it was only operational. So this only speaks in effect to the operational phase of a building. It doesn't consider the embodied carbon, so to speak. Not that the embodied carbon wasn't considered in the overall approach, that's coming. But the focus was really on looking at operational carbon. So just to give you an update so that you understand, what's happening globally with all of the GBCs, there are 14 green building councils that do have a net zero scheme. South Africa was one of the first to develop them. We'll take you through, some of those details. And in theory, with all of the green building councils, to date, there are, over 804 buildings that have been net zero certified. And as I said, the focus here is more on operational carbon as opposed to looking at the whole life carbon. But I think what's inspiring about this movement, and we sit in on a lot of these meetings, is understanding the scale of global action and collective action by GBCs in different countries. When we have these meetings, it's us, it's the Australians, the Americans, the UK, but it's also the Philippines, Germany, the Netherlands. You know, there are a whole bunch of countries that are on board and driving change relative to their local context and their local policies and what their market has an appetite for and needs to be pushed. You know, they're developing localized solutions. So, you know, there's no prescription about what each country must do. It's around coming up with local solutions. So as I mentioned, the GBCSA came out with a net zero scheme, and you know, I'm just sharing this with you so that you're familiar with the terminology when you see this on a project, because obviously, you know, looking at carbon, part of the complication was around understanding at what point in a building's life cycle are we evaluating either the carbon or the water, the waste, or a biodiversity impact. But in effect, the point of these certifications, these ratings, is to reward projects that either minimize their impact or actually positively redress them, where they would then qualify for a net positive rating. So for example, if a building generates more energy than what it needs to use, that would make it a net positive building. If a building actually collects and then, you know, either recycles more water than what it needs, that would be a net positive water building, which is quite difficult to achieve. So we have been providing support from a training perspective within the market, and then we've also been supporting local initiatives that are trying to drive and really guide the net zero ambitions within South Africa. I think what's interesting to note is that the scope of net zero can be applied to other categories. The GBCSA was one of the first green building councils globally that brought out a scheme over and above carbon. So, you know, we were one of the first ones to bring out a scheme, but definitely one of the first, if not the first, to bring out a net zero water and a net zero waste scheme. And we are still the only green building council that has got a net zero ecology rating. And in effect, what that is, it's really looking at the biodiversity on your site before and after, and understanding what the net effect of that change is. So understanding net zero carbon from an operational perspective is understanding that it's efficiency first. And this is obviously where, you know, a structural engineer would get involved in terms of working closely with your architect. If a facade engineer is appointed on the project, there would also be close collaboration there, and, you know, with the mechanical engineer to understand what your building envelope is. And it's really about optimizing that energy efficiency. Only once the energy efficiency has been optimized do we want to resort to renewables. And the focus here is really in understanding that we want to optimize our demand side solutions before we go to supply side solutions. And a very easy way of explaining it is that we don't want to be putting PV on an inefficient building and then rewarding it with a net zero rating. So we want to make sure that the design from an efficiency perspective has truly been optimized. The next option to get to net zero is to use on-site renewables. We acknowledge, we recognize that there are limits to certain building forms. So not all tall buildings in the city center, you know, have a form to accommodate enough roof space, obviously, for them to generate enough PV to satisfy their building demand. So once you have optimized your options for on-site renewables, you can then look to off-site renewables. And then as a last option, you can look to carbon offsets to demonstrate that you are net zero carbon. The issue of offsets, and this applies to the embodied carbon debate as well. So I think it's worthwhile raising now. Can sometimes raise a bit of a controversial reaction. Some people believe that it's seen as perceived as, you know, buying your way out of the problem. From a GBCSA perspective, and which has been well researched and is very aligned with the World Green Building Council, is understanding where we are now and where we need to get to, and how realistically can we move the market in that direction. And the goals are very ambitious, there are certain buildings that just, they've already been built, they're already located in a certain location. You can strip them out, and yes, you can optimize the efficiency, but as I've said, there's only so much that they're going to be able to reduce their demand by. And for example, if the policy and the regulatory context in a country, which South Africa is potentially an example of, doesn't allow for the purchasing of any offsite electricity, offsets then do become the next option. But it's about seeing it as a transitionary solution, not seeing it as the only solution. So at the moment in South Africa, we've got about, this graph is a little bit outdated. So we actually have about 22 net zero certifications to date already. Most of them are carbon. I see, this is 18. So the extra 4 are all carbon, and they're all net zero and not net positive. But we do have projects within the other range of categories as well. Clearly the market demand at the moment is in favor of net zero carbon. So maybe just some projects just to give you a feel, and you might have worked on similar projects, but obviously industrial projects from an operational net zero carbon perspective are always prime opportunities because of their roof space relative to their energy demand. This is the Greenfield Industrial Park. I think I just want to point out the transparency around offsets associated with these projects. So for example, you can see on the slide here, it says including 0% offset purchased. So whatever the role of offsets is in the project, that is declared, and there is transparency around that. And in effect, there is a like I said, you've got to go through those pathways, and you've got to demonstrate that you've explored all options before you can resort to options. I've also loaded the link to the GBCSA website case study, which you can go and download and kind of look at the building features that allowed it. But as an industrial building, the advantage here was looking at minimizing the lighting with energy efficient lighting, and then there was a PV installation installed. This is another net zero project, which was for a trout farm, and everything actually had to be off the grid. So they had PV, they've got a small bit of hydro, but it's very tiny. But in effect, had to make sure that they really optimized their building design in order to be able to run off what the PV can generate, and then also obviously put in batteries so that they can store any excess energy that is created. One of the things we also had to differentiate, and this is interesting from an embodied carbon perspective, and I'll raise it when I look at that in more detail a little later on, is understanding at which point you get projects to demonstrate that they have thought about carbon. So at our operational perspective, we allow projects to say, yes, you have got a modeled version here. This is your design intent. We can go forward. This project actually had measured data. So they had 12 months of operational performance data. And so the way the net zero schemes, the way the net zero schemes work is in effect that they expire. So once you've demonstrated that you have come up with a design, after 3 years, you then have to actually show to the GBCSA and to the market, yes, that building is operating as per your intentions and as per the design, and then submit the 12 months operational data in order to demonstrate that, yes, it is actually net zero carbon, in order to retain the validity of your certification. Here's an example more at scale, and I thought, more interesting for structural engineers. This is an office. It's in Johannesburg, Lugaro. It got a 6-star Green Star rating for an office. And they obviously looked at each facade and basically came up with a different design in order to respond to the orientation. But in doing that and in using, strong passive design principles from day one, they were able to really optimize their energy efficiency. So, with a limited kind of roof space, they were able to achieve net zero. So those are some examples of net zero carbon. We do, we offer more extensive training on this if you want to understand. I'm not going to go into detail, but if you want to understand concepts like level 1 and the modeled versus the measured. So the whole net zero debate has raised some really interesting questions around, architectural design and around the market appetite for certain aesthetics, particularly, like kind of see-through glass boxes, which, like in the last, I'd say 10 years, obviously have become very popular in South Africa, and questioning, can those buildings actually ever be net zero? And so, there's some very strong opinions about people on the side of the fence to say yes versus, organizations indicating that it's no. But I think that there are many conceptions around net zero carbon that need to be investigated in order to understand, is that building able to achieve it before an assumption is made? And so I've shared the resource to this for you to go and read examples of where, one might think, oh, this building can't actually achieve net zero, but we have a global database of examples of buildings that can. It's not to say that they would necessarily all apply to South Africa. I'd be interested to know, who listening today is aware of the C40 South Africa Buildings Program. It was launched in 2018 and is actually officially finished. It came to a close in August this year. It was funded by C40, and we have our 4 major metros as participating cities. We are Tshwane, eThekwini, Johannesburg, and Cape Town. And the program was orientated around each city developing legislation, a bylaw that moves new buildings, so this is only new build focused, to be net zero carbon by 2030. It was an incredibly successful program. We always tell the story with a lot of pride. We weren't a formal part of the program, but we obviously supported it and, showcased the program on many of our platforms because it really had many examples of cities demonstrating strong leadership and actual action towards sustainability. I think that there's a lot of policy fatigue in our kind of understanding around, change in South Africa. We obviously have many great policies, and it's really around the implementation. And so this program was really about saying, what bylaw can we put in place in order to promote and support getting to net zero carbon by 2030 for all new builds? One of the amazing success stories that has come out of it, and some of you might be aware of this, I'd be interested to know, who's doing work in eThekwini, is that eThekwini published a green building incentive policy. And so, it's out for public consultation and obviously still needs to be ratified, but it comes off the back of a green building policy that has been already approved. But in effect saying that if you have a green star rating or any other certification via GBCSA like EDGE, you would then qualify for a rebate on your monthly property taxes. And there are certain thresholds that have been set for that. I've taken a screenshot of the very significant thresholds that are set for, net zero carbon, which speaks to, 50%, which is huge. Whether or not those will remain in remains to be seen. Feedback was solicited from the public, with comments closing on the I think last week, Friday, on the 12th of November. We will wait to see what happens with that. But all of the cities are in some way or not developing a bylaw to support the implementation of net zero buildings by new builds by 2030. For those of you who aren't aware, this also came through a collaboration initiated by eThekwini with support from Sustainable Energy Africa, who were the program coordinators for the C40 new build program, as well as ASHRAE, and we also supported. But we developed a guide two teams to say, well, listen, we've got this target of net zero carbon. How do we get there? It's really fun. It's user friendly. I encourage you to share it with your teammates, with colleagues. And it looks at, really even just understanding things like, what's the culture? What's the mindset? What type of team do you have? Who do you have on your team? Who needs to work together? So they're obviously high level kind of technical guides, when you're looking at how much space you need for, renewables, but it also focuses more on the process side of things, which I think is useful. So for example, it illustrates the value of setting a target. So this was for an office that was extracted. So typically, as a rough benchmark, a lot of the offices at the moment are between about 150 to 200 kilowatt hours per square meter, whereas we want to be aiming for about 50 to 70, and breaking that down in terms of benchmarks that can then inform a design process. So, the tenant loads can't be more than 20. To the electrical engineer, this is the lighting design. How much natural light do we need to bring in to hit this target? So have a look there, and then just as an update, what else is happening and trying to push net zero carbon, is we have got an improved building standard. I'm sure many of you know about this already. The SANS 10400 XA has been updated, and the energy consumption thresholds were, improved. So, they're stronger targets to aim for, and they're quite considerably changed. So that's a step in the right direction. And then government has also mandated the EPCs, which are called energy performance certificates for operational buildings. So what this means is that by next year, I think it's the 8th of December or the 22nd of December, all buildings that trigger a certain threshold, and it's, they're typically either over 1,000 or 2,000 square meters, and it's mainly for offices and like public buildings, they have to declare their energy performance via a certificate like this, which also needs to be submitted to SANEDI. So it's a declaration of your energy performance over 12 months. It then gets rated, keeping in mind that the benchmark used is a SANS benchmark, which includes plug loads and kind of tenant loads. So it's not, but at the moment the standard was unable to reference another benchmark. So those are just two strong legislative drivers that are aiming to promote energy efficiency, as many people say is the first fuel to be considered in the road to net zero. These are obviously the standards that have been set, we know are not strong enough in order to kind of move the market where it needs to be, but it is moving the bottom end of the needle. Just want to see where I am for time. So I think, many of you, obviously being structural engineers, you're aware that, there's the operational side of things, but obviously, from a carbon perspective, but also, what would interest you particularly would be the carbon associated with the materials that go into building a building. And, there are obviously various statistics that abound, but as a, order of magnitude, if about a third comes from operational emissions, about 11%, of global emissions is associated with embodied carbon. And whilst that might be smaller than the operational amount, and you'll see some slides that I have on some projects that we've done, one needs to keep in mind that we are moving into an era of rapid urbanization, particularly within African countries, both primary and secondary countries, where the building stock is, in some estimates, expected to double. So it's very much speaking to new build and, kind of creating that embodied carbon jump. So in the last, 3 to 4 years, there has been a significant increased focus on embodied carbon as part of a whole life carbon approach. So the focus really did start on operational carbon, and that's when all the targets were set. what has increasingly happened and this is mainly driven actually a lot by a European context and more of an American context, is the decarbonization of some of their grids has meant that the operational component and the carbon associated with that has decreased, as well as really kind of very strong legislation in certain countries that is driving building performance efficiency, which relatively makes the embodied carbon component significantly more and has increased that focus. So the figure that I've got here is from the London Energy Transformation Initiative. They're called LETI, and they're a really interesting organization. Some of you might already be familiar with them, but they've got great references and great resources. So if you're not familiar with them, I would highly recommend that you check them out. But in effect, the pie charts that you're looking at on the left-hand side would be the carbon breakdown. So the yellow would be operational energy. And then the pink bits would be your embodied carbon, as well as it's your embodied carbon, but across the whole life. So it's not just upfront carbon. And then the transition to the pie charts on the right would be a really optimized building. I think in this example, they put in heat pumps, and you can see what the relative proportion, then is of embodied carbon, and how, that carbon in effect stays, there forever, and there's not really any scope to ever decrease it. So this has really created a transition, a renewed focus on understanding what the role is of embodied carbon in our project planning, in our project design, and understanding its future and long-term impact. And so within the Advancing Net Zero campaign, a lot of the terminology and the focus then changed to the whole life carbon vision. So yes, a big focus still on net zero carbon, but also understanding that we need to have a similar target for net zero embodied carbon, sorry. So maybe just a little note on definitions. And just to clarify, that whole life carbon looks at the emissions from all of the life cycle phases. So, you're looking at both embodied and an operational carbon, whereas upfront carbon really looks at the carbon only associated with the materials production and the construction phases. So I thought it was worthwhile noting, what these targets are, and getting some feedback around, not that you have to pop it in the chat, but just, thinking to yourselves how realistic you think these targets are, because the World Green Building Council's vision is that by 2030, which is really not that far away, we would have 40% less embodied carbon, with a significant upfront carbon reduction. And that by 2050, we would have net zero embodied carbon. So that's a very ambitious target. I've popped the link in the slide as well, but obviously that's what today's session is about, is just unpacking some action items that structural engineers can take in reaching this target. So this is just a nice graphic to kind of demonstrate the difference between the different forms of embodied carbon, and upfront carbon is really where a structural engineer would want to get involved in terms of design choices and efficiency of design. I like this graph. I always find it very helpful, and this really looks at the life cycle. So it also differentiates nicely between whole life carbon, which you can see is in the blue, and if you can see with my mouse, it looks at stages A, B, and C. Embodied carbon looks at those similar stages, but it's understanding that operational carbon phase then gets extracted from embodied carbon, and the upfront carbon is cycles A1 to A5, which gets referenced quite regularly, and it's worthwhile becoming familiar with these because a lot of the information and the feedback and the metrics are structured around this. And yeah, this is another similar graph that also basically, a lot of the terminology that you might be familiar with would be, cradle to gate or cradle to cradle and cradle to grave, in understanding where that cutoff line is within a building's life cycle. So from an embodied carbon perspective, and particularly from an upfront embodied carbon perspective, you will most likely be familiar with looking at the carbon intensity of materials that you're able to select, typically with steel and aluminum and cement being not desirable products to specify, even though obviously the majority of our buildings are made of that. And then obviously things like straw and timber having a very low embodied carbon factor associated with them. And you might have already engaged with some of these kind of databases on your projects. So, it ranges from that within, I think, the structural engineer's sphere of control over to elements that are quite future thinking, really looking at alternative ways of supplying concrete and steel. Chris and I were chatting before the event started, and I was looking at some of the targets. And fundamentally, we know that we're not going to be able to design out materials. There is a certain material impact associated with every building. And it's understanding how those materials are potentially being manufactured and produced. And a lot of the major, steel companies are getting behind a net zero steel by 2050 target. Mittel has, made very public commitments to that. And that really speaks a lot to alternative supply methodologies for any of their furnaces. I mean, their alternative technologies, but mainly the solutions that they're looking at, are kind of hydrogen economy related. And one also has to consider the trade-off that alternative suppliers would have to be considered against in comparison to, residential consumption, at an operational perspective, how that would be prioritized within a national grid. But I think what is really promising is that without this supply chain transformation, we're not going to get to a lot of those embodied carbon targets that have been set. So these are really, really vital. And I think that, the commitments are bold. They're definitely what we need. And having a lot of the big players come on board who have put in millions in kind of research and development and are also harnessing climate financing support in order to come up with factories where, in the next 2 or 3 years, the whole factory needs to be powered by an alternative supply and not by a fossil fuel. Typically, because a lot of these, steel and cement were also associated with kind of mining and close to coal-fired power stations, particularly in South Africa as well. So interestingly, so just to look at this role of embodied carbon versus operational carbon, and where should your focus be? And I don't think it needs to be a one or the other, but it's about framing the context for analysis. We have recently issued a report where we did research with Diversity, who are a residential property developer, mainly in Johannesburg within the city centre. Arapworthy appointed consultants who did the research and did all the technical the kind of study work. But we asked the question, so what is the carbon cost of location? So, intuitively, anecdotally, one would assume that something that sits on the periphery of a city, far away from the urban city centre, where families have to travel in for work opportunities and for schooling opportunities, would have a higher carbon cost, particularly in South Africa. Understanding our kind of spatial history associated also with urban planning in South Africa, but also the fact that we've got no electric vehicles, and that also private car use is also significantly high. And so one would, understand that would likely be larger if you are, on the outskirts of the city. But we wanted to actually quantify that because nobody has really looked at putting a number to that, an order of magnitude, which is what we wanted to understand. And we wanted to understand the long-term impact of where you locate a building, and that was particularly a residential development, what trajectory that locks you into for the next, 60 to 70 years. And if we, continue with certain building patterns, what is the cumulative effect for cities in South Africa? So I'm not going to go into the results in detail. We are actually having a session on Friday, next week Friday. I'm flying up to Johannesburg. Don't judge me on my carbon footprint. I haven't taken any flights since COVID, so it will be my first. And we're actually doing an in-person event, and I think it's our second in-person event since March 2020. We haven't had any. We've had one, so this would be our second. So if any of you are members and would like to join, please do come. There is still space available, and the Arab team will be unpacking all of the results. But what I wanted to share today was, the study looked at 4 different locations, and 2 different locations, but within each location a different income group for a family, because that influences energy, operational energy consumption. And you can see, the inputs that we had to use, were also based on, the data that we have available in South Africa, which is very limited, as many of you will know if you have tried to do any, embodied carbon calculations. But on average, the embodied carbon component in comparison to the operational component was between 12 and 13%. We need to keep in mind that we have a very carbon intensive grid. And so obviously, as we decarbonize our grid, that is going to become more, the embodied carbon component is going to become significantly more important to consider. And we also need more studies like this to understand what that could be across different sectors. What was interesting is part of our study, and which was quite novel, and we haven't seen anybody else do it, and that's why we wanted to undertake it, was we added the travel component. So then we added the travel associated emissions from that location. And as you can see, what's really interesting is that, the travel component totally knocks out everything. So, looking at this, if you as a structural engineer are in a leadership position, your role is really to, speak to your client and make sure that buildings are being built close to amenities. So, as long as mixed use developments are being promoted where car trips and transport trips can be reduced, that would be a significant plus in terms of our long-term and total carbon ambition as a country. So in terms of what you can do, firstly, set an embodied carbon target. So this, sounds simple, but it's a bit trickier than what you may think. So typically, when you look at, net zero embodied carbon targets, there are 3 general types. So there's the kind of company organization-wide target, which, you might be working on projects for certain clients, might be working at, at a strategy level and at a portfolio level that you can inform that. But typically, I think most structural engineers will engage with project level targets and specification procurement level targets. And typically they come in 2 ways. Either there's a carbon intensity limit that is set, or it's a relative target in terms of a percentage reduction on a baseline. So the more credible ones that I've come across would, and there are quite a few of them. There was a really interesting study done that looked at over 1,000 buildings, kind of came up with common ranges of carbon intensity values. I've got all the resources on a slide, so you can have a look at the reports. They're all quite long, 100-page technical reports. Letty, once again, has also come up with absolute targets, which they've based quite heavily on the embodied carbon benchmark study. Architecture 2030 has got a relative reduction target. I'm going to talk you through some green building rating tools. And then there are obviously a lot of like commitments and signatories. So there are a whole plethora of them, which might, you might find useful signing up to if it's, relevant to your client. So just having a look at some of these absolute targets and having a look at an office down there, maybe, that's what you typically work on. The kind of order of magnitude that has come out for offices is, 1,000 kilograms of CO2 per square meter, but we want to be aiming for 600. And what Letty did is they kind of set this up against design targets. They included the reba targets as well that have also looked at embodied carbon to understand, and what is nice for different typologies, which I think is great, where average performance is and where we want to be going. So this is a kind of proposed rating system that has come out, and it's ready to shift that peak. So you can see in the orange, that's where the current kind of design would be, and it would be, back to there. You can see the 1,400 to the 1,800 range, whereas the top performers are in that kind of 200 sweet spot, whereas most average buildings are ranging around the 500. I'd say no, sorry, but less about the 400. So these are obviously UK based. The organization is UK based, but I think that in understanding, I think targets are always useful to understand the order of magnitude, and then that can galvanize action. This is the 2030 challenge from Architecture 2030 organization, and here we've got relative targets that's to 40%, then a 45%, and then a 65% decrease, which is significant in comparison to some of the feedback we have had and experienced. LEED, for example, version 4 has got a credit that rewards projects if they've got a 10% reduction compared to the baseline building. Our engagement primarily has been with the Australians, obviously GBCSA, Green Building Council of Australia, has got the Green Star system, which we adopted and then contextualized for South Africa. So we had a look at that, and they've just gone through a whole process of updating their tool, and they've included an upfront carbon project, the credit, sorry, or initiative. And as a minimum requirement, all projects must achieve a 10% improvement on a reference building. So every building going forward has to be able to demonstrate that. It's no, you don't get a point for it. It's a minimum expectation. And then the next target is set at 20% less, and then at 40%. And interestingly, we are going to adopt and update our new build tool. Some of you, if you did join the convention, we had it in person at the CTICC in the first week of November. It was really fabulous having an in-person event. Lisa Reynolds, our CEO, indicated and let everybody know that we are going ahead, and we are updating our new build tool. So it's, as Chris says, in the early 2000s, we kind of developed it, and it's in need of an update, and we haven't been able to gain sponsorship because of some issues, but we're going to do it together with industry. So we are calling on professionals for their time, for their interest, driven by passion, and because they want to leave a legacy and they actually want to be part of creating something and moving the market. And the intent really is to move that 4-star. So a lot of buildings that you might be more familiar with in terms of the work that you're doing, I wouldn't say across all of South Africa, but in a certain segment can achieve 4-star relatively easy. And we want to, it's time to push that needle. It's time to push that bar. So we're going to do that next year. We're very excited. If any of you want to join that process, this is a shameless, recruiting request, let me know. And, if you've got some expertise in this field, I would love to hear your input. And so we would be including, this credit as well. And so I think what's also interesting about the approach is that it's quite a phased, in understanding that if you register a project from 2020, you have to, meet the minimum expectation. But if you want to achieve a 6-star, you then actually have to demonstrate a 20% reduction. So, there are upfront embodied carbon targets that are set also across the different stars. And then excitingly, we also, and Chris knows a bit about this.
Sorry, Georgina, you need to start wrapping up, I'm afraid. I don't know.
Oh, really? Okay.
Yes.
Okay. Oh,
just so we can get into some questions just now, if there are any. Sorry to rush you. It's been very interesting so far.
Oh, no, that's fine. Okay, so yes, we are trying to develop a net zero scheme for upfront embodied carbon, and I'm happy to chat to anybody about that if you're interested in it. Many of you already know that you might know that there's a Structural Engineers 2050 challenge, and it's quite clear you need to eliminate all embodied carbon from your projects by 2050. I think it's important, obviously, to understand your sphere of influence in terms of integrating these options into the design process. And I've put some ideas here, but these are quite well documented, and I'm not a structural engineer. You would all be better versed at understanding what some of these options are. And then really an important thing I think is really about sharing and generating data. On your projects, try and motivate for EPDs to be created. If you're on a Green Star project, I will reward that as an innovation point, because it's around demonstrating market leadership, but also around sharing projects and what we think our targets are. Many of you have seen the ridge. If you are structural engineers, you probably very interested in the fact that it's got a CLT timber facade, which obviously has a significant embodied carbon reduction, and the use of eco bricks as a void filler under the toilets was also positive in terms of embodied carbon. Yep, you've got a role to advocate and to act. I've put some tools there and some closing remarks, but I think that's it from me. Thank you.